Let's talk about the present value of an annuity immediate. And this is an extremely important practical concept because this is just how you price annuities. We'll talk about mortgages in a second and the relationship to present value. So how do we get the present value of an annuity immediate? And what does that even mean? That means that if we have an interest rate, a per period interest rate J, and we have deposits or payments of P at the end of each period, and we do this for N periods, well, let's say the present value factor is nu. And remember, nu is 1 over 1 plus J if J is a per period interest rate. Okay, so we're asking, well, if we date this back by 1 period, what's the value? Well, it's times nu, P times nu. If we date this deposit back 2 periods, well, that means its value at the beginning is P nu squared. And we keep playing this game until we get to, let's say, the second class deposit or payment. That's P to the nu N minus 1. We have to discount this by N minus 1 periods. And then finally, this is P to the nu. Now, there's another important way you should think about this. And that is, let's say I owe someone P at the end of the first period. I owe someone P at the end of the second period. I owe someone P at the end of the Nth minus 1 period. And I owe someone P at the end of N periods. Or in other words, I'm paying someone back, and I make these payments P at the end of each period. How much do I want to put in an account to make all these payments, and in particular to only take money out of the account when I make these payments, and I only want to take out enough to make these payments? The answer is the present value of all these payments. That's the answer. So the answer is add up all these up. That's how much you need to put into the account. Why? Because, well, this P nu, whatever it is, accrues 1 period of interest, so that at the end of the first period, you'll have P to pay off what you need to, which is P. Take this amount. That accrues 2 periods of interest if it sits in the account. And if you have this, if you pull out exactly this amount at the end of 2 periods, then you'll have exactly P at the end of 2 periods to pay off this debt. Keep going. Take this amount. This will accrue N minus 1 periods of interest, so you'll have P at the end of the N minus 1 period to pay off your debt of P. And the same thing here, this amount will accrue N periods of interest so that you'll have exactly P when you need it at the end of everything. Okay. So add up all these, you let it sit in your account. This is how much you need to deposit at the beginning to take out money. Otherwise, let it sit just to pay off these debts. P at the end of the first period, P at the end of the second period, et cetera, et cetera. Okay. Okay, so, right, let's get a formula for present value. And this is very similar to what we did before. So just add everything up. Now let's factor out a P nu. Well, geometric series formula. And if you remember, 1 minus nu is 1 minus 1 over 1 plus j. Well, 1 minus 1 over 1 plus j is just j. So we have in the bottom just j. And you should check this. I don't know, it's a perfectly trivial check, but okay. Okay, so this gives us the formula for the present value of an annuity immediate. And like before, we have special notation. A and J is going to be this value here, what's to the right of the P, and this can be interpreted as the present value of annuity immediate, interest rate J per period, and periods, payments are $1 per period. Sorry, I meant to go back. That's because we'll just set P to be 1, and yeah. So I don't know why A is used for present value, and I don't really even know why S is used for accumulated value. I mean, I guess A should be for accumulated value, if anything, but again, this is standard actuarial notation, so you definitely got to remember A for present value, S for accumulated value. Okay, so in summary, present value of an annuity immediate is P, A, N, J. Again, N periods, P payment per period, interest rate J. All right, so let me talk about mortgages because this is really a very concrete example of present value of an annuity. So the way mortgages work is basically mortgages, just like all loans, are an equation of value. So meaning the amount borrowed is the value of all these payments when you borrow the money. And usually you borrow the money so you can buy a house and then you pay it off. It's not you borrow some now, some later, some 10 years from now, whatever. I mean, just your bread and butter mortgage is, I need money now. I need $300,000 so I can buy a house right now. Okay. And we'll talk about loans in general later on, but loans are the same thing. So the present value of all the mortgage payments is the amount borrowed. And in general, when we speak of the annuity present value, that's kind of the annuity value at this initial time. That's kind of how much the annuity is worth right now. So when you price annuities, it's how much the annuity is now, and that is the annuity present value. Now, for example, maybe if you've if you've ever done late night TV and you've seen commercials for annuities, you're probably up too late if you've ever seen that, but anyway, if you've seen commercials for, hey, you can buy annuities, the price of that annuity would be the present value of all the annuity payments. All right, anyway, so, right, so let's do an example. You take out a 30-year, $300,000 mortgage at a nominal monthly rate of I-12 is 5.1%. Find your monthly payments. Now let's do something interesting. Let's just use the first online mortgage calculator that pops up in Google to check your answer. And I also want to illustrate you doing this that very naturally and usually interest rates are given by a nominal monthly rate. Okay, so right, let's do this example. All right, so and after this, I'll finish up with a really interesting example. So here you really don't need a timeline, so I'm not going to really bother. This is just a plug and chug problem. So remember, I-12 is 0.051. So that means if J is the monthly effective interest rate, let's just call it monthly interest rate, then by definition, you divide by 12 to get 0.00425. Sorry, that. All right, so so let's just plug and chug. So I mentioned when I say a $300,000 mortgage, that colloquially means you're taking out $300,000. I think that should be clear. So $300,000 is whatever your monthly payments are. Well, we're just using the present value formula. It's whatever your payments are times. So it's not 30. Do not put 30 here. Mortgages are monthly payments, so it's 12 times 30. It's 360 monthly payments you need to make at this interest rate of a monthly interest rate of 0.0045. Okay, and you plug into your formula, which I'll just do once. It's 1 minus present value factor 1.0045 to the 360 over 0.0045, which is going to be 184.1791 P. And so, all you do is, well, let me just write this out on the next page. So what do we have? We have 300,000 equals 184.1791 P. So P is 1628.85. All right, so yeah, let's check this. All right, so online mortgage calculator. All right, so 300,000. What do we say? 5.1, 30 years. And well, they do a little bit of rounding. So they get $1,629, which, I mean, that's pretty darn close. That's off by our answer by 15 cents. So, I mean, they do probably rounding differently than we do. So, yeah, so the mortgage calculator checks with exactly what we did. Okay, so let me finish off, and I think this video is getting a bit long, but I do want to finish off with, I do want to finish up PowerPoints. Okay, so this is a very typical example of something that might be on a quiz or homework or exam. And it's combining both the present value and accumulated value formulas. So a person deposits $500 at the end of each month, with first deposit starting June 30th, 2003 and ending June 30th, 2015. Interest is I-12 is 0.06. The accumulated value is used to pay for monthly payments of P starting August 30th, 2015 and ending July 30th, 2020. Find what P is. Right. Okay, so, right, so let's write things down. So first things first, let's get this accumulated value at the end of July 31st, 2015. So there's really not all that much to that. The first payment starts June 30th, 2003. So we're going to go back to May 31st, 2003. So we draw our time diagram. Right, so, right. Yeah, I'll end here. Okay, so May 31st. 2003. So June 30th is the next one. Maybe I can squeeze in one more. So this is July 31st. So that's a J, might not look it. Okay, so we go all the way to July 31st. 2015. Okay, so, right, this is 2 months, obviously. This here is going to be, and sorry, we're making $500 deposits. This here is, well, this is going to be 12 years. So 12 years, 12 times 12, excuse me, is 144, plus 2 months is 146 years. So 146 months, not years. 146 months. So the accumulated value here is 500 S 146. Well, I didn't get J yet. So let's, what the hell, use yellow here for J, so kind of alongside here. Right, so J is, so this gets really routine, especially for monthly interest. So we're given it's 0.06 as nominal monthly interest, so divided by 12, 0.005. Yeah, maybe I won't use yellow in the future because this is kind of tough to read even for myself, but anyway, so this was 12. Okay, so 146.005, and right, so you plug into your formula 107, 130.96. Okay. So that is how much we've accumulated. 107, 130, and 96 cents on July 31st, 2015. Let me just go back to the problem real quick. Okay, so 1 month later from this time, this July 31st time, this July 31st date, we want payments of P to start. And we want to know how much we can, what is P going to be? So, well, the answer is, I'm using this 107, 130, 96 cents to buy an annuity that lasts until July 31st, 2020, which is 15 years of monthly payments. Okay, which corresponds to, or rather, not 15, sorry, 5 years. 2015, 2020 is 5 years. I don't know why I said 15. It's kind of late here and it's a long day, as usual, but anyway. So that's 60 months. So let me draw the timeline here, starting at when we're going to start this annuity that I want. Okay, so, right, so it's, so here this is going to start July 31st, 2015. My first payment is August 30th, 2015. Whatever, I'll leave it. That's 2015. Fighting temptation to erase this. I gotta erase that. I think Zoom just told me my screen got paused for a moment. Be curious to see what that looks like. But anyway, so yeah, July 31st is the last payment, 2020. So this is P. Okay, so again, the price of this annuity is, well, I have $107,130.96 to buy this annuity. And I want to, again, make clear, this is how annuities are priced. If you're a company that buys loans, buys people's mortgages, you know, this is how much you will pay for this annuity. This is how loans are priced. This is not how I decided loans are priced. This is not how I decided annuities are priced. This is just the way, you know, economics and finance works. All right, so anyway, so yeah, so this is the price of the annuity. This is how much I have to spend on this annuity. And yeah, so the price of the annuity value, whatever, is given by the present value of this annuity. And again, this is 60 months, which is 5 years. Payments are at the end of each year, and that's why I'm writing the July 31st, 2015. So this fits into the annuity immediate timeline. So 60 months at, I didn't say there's an interest rate change. So implicit is same interest rate, monthly interest rate of 0.0045. So this is going to be 51.72556p. So last but not least, just simply, you know, divide both sides here by 51.72556. And you will get P is 2,071.14 So I would suggest actually plugging into your annuity immediate formula to check this. So you can just plug in and check. It's not a bad idea to check that you do get 107, 130.96. But anyway, okay, so next time we'll talk about annuity dues, go through the basics of that, and then we'll kind of get into more interesting annuity type situations that are still very, very practical for real life business and finance situations, particularly real life corporate situations. You as an individual are probably not going to buy annuities, buy debt from other people or other companies. I certainly don't, obviously. But, as a corporation, you definitely might. And we still will do annuity loan situations that are very relevant to a personal investor, or if you're a small business owner. All right, anyway, so long. Sorry, this is such a long video, but new videos will probably come maybe late next week or late this week or next week. So long, take care.